Lesson 36, writing and solving proportions. We're going to start by talking about similar figures. A similar figure has the same shape and may have the same size. Now, two figures are congruent if they have the exact same shape and same size. A symbol for congruent is an equal sign with a similar sign above it. So congruent figures have exactly the same shape and the same size. If you have two triangles that are similar, let's say triangle ABC is similar to triangle DEF, this little symbol in between is read is similar to. If you pay attention to the order of the letters, then we know that the angles in the order, so the first angle, angle A, will be congruent to angle D. Angle B corresponds to angle E, and angle C corresponds to angle F. When they are similar, the angles will be the same. The sides will be proportional. So we could follow the order of the letters and say angle A is congruent to angle D. Angle B will be congruent to angle E. That means the same size. And angle C will be congruent to angle F. Then we can look at the two letters. So side AB corresponds to side DE. So remember, if you look at this is the first two letters, AB, first two letters DE. So BC, we could say side BC corresponds to side EF. Though that's the last two letters, BC, EF. We've got to keep them in the same order. And finally, AC will correspond to DF. The first and the last letter, AC, DF. So in similar figures, just right here, the angles will be congruent. So in similar figures, the angles are congruent. And this little symbol right here just again means is congruent to. So in similar figures, sides are proportional. So the angles are congruent and the sides are proportional. So we can say AB divided by DE will equal BC divided by EF, which will equal AC divided by DF. Notice that there's not a little bar there. That means, without the little bar, that means the length of. So the length of AB divided by the length of DE will equal these lengths as a ratio. And these will set up a correct proportion for similar figures. So let's give an example where we have two triangles. We'll do ABC. We'll say AB is 2, AC is 6, and BC is X. Then we'll do a similar triangle, DEF. DE is 4, DF is 12, and EF is 16. Now if we wanted to find X, we could set up our proportions. We could say AB, 2 divided by 4 equals 6. Well, wait, BC is X divided by 16. And that's also going to equal 6 divided by 12. Notice that they're all 1/2. So we can see from this that X is 8 units long. So the scale factor, if we were looking at this example, from the larger to the smaller, that's what do we multiply 12 by to get 6. So from the larger to the smaller would be 1/2. If we wanted to go from the smaller to the larger, we do the reciprocal of that, which is 2. So it's going from 6 to 12, we multiply by 2. So if I say from larger to smaller, I'm going to put the larger number in the denominator and the smaller number in the numerator, so 6 divided by 12. If I'm going from smaller to larger, I put the smaller one in the denominator and the larger one in the numerator, so it would be 12 divided by 6, which is 2. Now we can use proportions to find indirect measurements. So we're going to use these proportions to find indirect measurements. So let's say we had a super tall flagpole. Okay, so here's our flag, and we want to know how tall it is. Well, we can measure the shadow and say that it's 24 feet. This is just the shadow. And let's say we are exactly 5 feet tall. So that's our height. 5 feet tall, and our shadow is 6 feet. This actually forms with the shadow made by the sun similar triangles that are right. So we can form a proportion where we can take the shadow lengths, or the shadow lengths, and make a fraction, so 6 out of 24 equals, and then we take the height of the person and of the flagpole, which is 5 to x. Then we can solve by cross-multiplying. So 5 times 24 equals 6 times x. Whoops, I should do a dot right there. And we're going to divide by 6. 6 goes into 24 4 times, so x is 20 feet. And our flagpole will be 20 feet tall. And that's the end of the lesson.